Okay, so here we are with question 9 off the June 2008 Core 2 paper. Okay, so last question. And here we are, is sine 2x equals sine of 48 degrees. A couple of things going on here. First of all, we've got a 2x to deal with. And the other thing is that you may be more familiar with when this is a number, but it's actually easier when it's a sine of another angle. Okay, so let's think how we start. We start by saying theta equals 2x. So you're just solving sine of theta equals sine of 48 degrees. Now it's worth looking at your range. If 0 is less than x is less than 360 degrees, that's our final range of values for x, but we're looking at theta to begin with, and theta is 2x. So to decide the range for theta, we need to think, okay, 2x is going to be between two things. So what we're really just doing is doubling through all the values in the inequality. So you should be able to fill in the range of values for 2x just by doubling everything through. So, and of course 2x is theta, so we want the thetas between the values you've just got. Now, we said that sine theta had to equal sine of 48 degrees. Normally you'd do an inverse sine to find your theta 1. So theta 1, normally you'd inverse sine something, but here we know that sine of theta is sine of 48, so theta 1, the first value that theta could be, is blindingly obvious. If sine of theta is sine of 48 degrees, then theta could equal 48 degrees. And theta 2, you're going to find out in your normal way. You should have remembered your procedures for how to find theta 2, whether it's a sine or a cos or a tan. It's on the front of your chapter 5 booklet if you've forgotten. And then, to get all the values of theta in this range, you're probably going to find you're going to need to add or subtract a complete revolution, 360 degrees from some of these values to get the remaining ones in this range. So I think you're going to get at least 4 values of theta, probably exactly 4. And you're going to get theta 3 and so on. Okay, and then, once you've got all of those, you know that theta is 2x. So if you've got theta values, you can say that 2x equals that one and 2x equals that one. So you're going to have to divide them by 2 to get your theta values. Right, I've done too much for you there. Okay, if that made sense, then forget all about this. Have a cup of tea, come back in 10 minutes and see if you can do the question. Right, on to 9b. Now we've got to solve 2 sine theta minus 3 cos theta equals 0. This has got sine theta in it, and it's got cos theta in it. Watch out for things like, it hasn't happened on this paper. This paper didn't have a sine squared theta on it at all. If you see sine squared theta, then you should be thinking about that identity that relates it to cos squared theta. But that didn't happen this time. We've got plain sine theta, we've got plain cos theta. Can't be this business with sine squared and cos squared, so it's got to be the other one, where you know that tan of theta is sine theta over cos theta. So if I've got 2 sine theta minus 3 cos theta equals 0, the trick is to divide by something that turns this into sine theta over cos thetas and makes this term very nice indeed. So what can I divide by? That gives me just a plain number here and gives me a tan theta term here. And you're going to end up with a number times tan of theta minus a number equaling 0, which will turn to tan theta equaling a number. And then theta 1 will equal an inverse tan. And theta 2 will equal something appropriate. And we're only going up to 360 degrees, so that's going to be it. And that's the end of that question. And that's the end of the paper. Hurrah!